17. Which of the following statements about how light waves travels is correct? A. Light waves travel the fastest through solids and slowest through gases. I know that's not correct because light waves don't normally travel through brick walls, and they don't travel through brick walls, and they don't travel through people. B. Light waves travel faster through solids than through air. Once again, light waves do not travel faster through solids. More times than not, they get stopped by solids or extremely slow down. C. Light waves travel faster through air than through solids. This is absolutely correct because light waves travel through the least dense substance the fastest. They travel through the least dense substance the fastest, and then they travel through the most dense substance the slowest. And then D, light waves travel faster through liquids and slowest through air. And that's not true. 18. A student views a table of the speed of sound waves in three different materials. So we have air, and that's going to be the slowest. And we got water, it speeds up some. And then we got glass. It travels the fastest in glass. Which conclusion can be drawn based on the information in the table? So just like I do for all the other questions, I'm just going to break it down into its part. So A, sound waves travel faster in glass because it has a lower density, and that's not true. Glass is actually more dense than the other materials. B, sound travels faster in glass because it has a higher density than the other materials, and that's true, and that part is true as well. So answer choice is B. Let's see why it's not the other answer choices. C, sound travels slower in water because it has a lower density than the other materials. So it doesn't have a lower density than gas or than the air, so that can't be true. D, sound travels slower in air because it has a higher density than the other materials. Actually, air has the lowest density because the particles are spread the farthest apart. 19. The table shows the speed of light in three states of matter. So now we're looking at the speed of light. So once again, when you look at the speed of light and speed of sound, understand that as you go through the speed of light, it goes fastest from a gas, then slows down in a liquid, and then slows down the most in a solid. And that's what's being shown right here. Look at the speed. It's the fastest here, but then it's the slowest here. At what point in time would the speed of light decrease? So as long as it's going from air to water or glass, it's going to slow down. So A, when the light travels from water to air, that means it's saying that the light is actually going up. But if you look at these numbers, that means it's actually increases. So it wouldn't be decreasing, so that can't be right. B, when the light travels from air to water. So if it's traveling from air to water, that means it would decrease. So our answer choice would be B. So that is correct. C, when the light travels from glass to air, if it travels from glass to air, it's actually going to be speeding up if you look at the numbers. So that's not true. D, when the light travels from glass to water, once again, it would be speeding up. So that's not true. 20. Through which of the following would sound waves travel the fastest? Remember, sound waves are mechanical waves, and so they're longitudinal mechanical waves. So they travel the fastest in solids, they slow down in liquids, and they travel the slowest in gases. So a vacuum, no, because there is no medium for a sound wave to travel through. Matter of fact, it wouldn't travel at all because there's no solid, liquid, or gas. B, a pool of water. Well, a pool of water, that is a liquid. So we know that can't be true because they travel fastest in solids. C, Earth's atmosphere. That can't be true because we know they travel slowest in gases. And then D, a railroad track. A railroad track is a solid, so they would travel fastest in a railroad track. And number 21, the data shows the speed of sound through air and seawater at 21 degrees Celsius. So let me go ahead and circle speed of sound. So that lets me know, I'm just going to go ahead and put my little diagram, SLG. That helps me remember that they travel fastest in solids and slowest in gases. How does the speed of sound in seawater compare to the speed of sound in air? So let's identify this. Seawater is actually a liquid. And then, of course, air is a gas. So knowing this, they travel faster in liquids and then they travel slower in gases. Why? Because liquids particles are more tightly packed and the gases particles are less dense and the least tightly packed. A, the speed of sound is faster in seawater because the molecules, well, first of all, the speed of sound is faster in seawater. That's true. Because the molecules in seawater are closer to each other and less dense. That's where they messed up. They say they are closer to each other. That's true. But they are not less dense than air. B, the speed of sound is slower in seawater. Nope, we can cross that out because we already know it's faster. C, the speed of sound is faster in seawater. True, because the molecules in seawater are closer to each other and they are more dense. So all three parts of this are correct. So our answer choice is C. D, the speed of sound is slower. Nope, definitely would not be that. And ladies and gentlemen, that is our Waves Review Part 2 question analysis. So ladies and gentlemen, we hope you enjoyed it. Please like, share, and subscribe. Ladies and gentlemen, enjoy your day and have a positive, productive day. Peace.